Welcome back to 2.1, Part 2. And here's where we will look at the new rules for finding derivatives. And I do give most of these on the exam. It's not too much about memorizing what the rules are, but just about using them. So our goal to motivate us, find the derivative of, this is number 8 in our book, find the derivative of this function f of x equals 4x to the fourth plus 2x cubed plus 8x squared minus x minus 10. So just think for one moment about doing that with the limit definition, the h going to 0, the f of x plus h stuff. Kind of a nightmare to do this all written out that way. So this is why we need these new rules. So we're going to build up all the pieces that we need to be able to take the derivative of this polynomial. So let's start at the end there with that negative 10. So if, rule number one, if our function y is equal to a constant c, a constant function, then the derivative is equal to 0. And you can think of the picture that the graph of y equals c is just a horizontal line at height c, and that has slope m equals to 0. So a constant function is a horizontal line, so the slope is 0. So the rule here is what I'm going to give you on the exam. So this is what you'll see, so you'll know what I'm going to give you, that the derivative of a constant is equal to 0. And so an example would be the derivative of just that number, negative 10, is equal to 0. And take a look at this notation, this bracket, square brackets with the little prime that we use in our derivative notation, is a way, and it's a way I like to use to show that I'm going to take a derivative. It's kind of an instruction. Take the derivative of what's inside, and the result is 0. Rule number 2, if we have some sort of variable with a power on it, for example, y equals x to the nth power, then the derivative is n times x to the n minus 1 power. So we can say in words, the power comes down in front and multiplies, and we subtract 1 from that power. And again, the way I'll give that on the exam is in brackets with the little derivative prime. The derivative of x to the n is n times x to the n minus 1. And here's some examples. All right, in brackets, x cubed with the little prime says take the derivative of x cubed. Here's the 3 coming down in front. That cubic power comes in front, and we subtract 1 to get our new power, 2. So the derivative of x cubed is 3x squared. The derivative of a plain old x, the shortcut is just to realize that it's going to be a 1. One way to think about it, though, is that x is the same as x to the first power. There's an invisible 1 power in there. So that 1 comes down, and we subtract and get left behind with a 0 power, and x to the 0 is 1. So 1 times 1 is 1. So hopefully you don't have to go through all that logic, but that's why it works. Now, a couple of special cases that we'll need to be able to work with. Special cases, okay, read that. My writing's bad today. So what if we have our x variable on the bottom of a fraction? Our rule does not have a fraction in it, so we're going to have to rewrite using a negative exponent. You might remember this. There's some extra support on this page down at the bottom if you want a quick review of exponents. But 1 over x to the third power can be rewritten as x to the negative 3. And notice how I still have the brackets to take the derivative because I'm just rewriting. I haven't actually done the derivative at this point. Now taking the derivative of x to the negative 3, the negative 3 comes down, and then I subtract 1. And be careful with negatives. Negative 3 take away negative 1 is like negative 3 plus an additional negative 1, which is negative 4. And then the last special case here, square root functions, we'll see those a lot. So the square root function can be rewritten also as a power. So we can use our power rule. And the square root function is equal to x to the 1/2. And so then when we take our derivative, 1/2 comes down, and 1/2 take away 1. If you don't remember how to do that, your calculator, remember, can help you with fractions. Please use your calculator to help you with fractions. But if you want to do it by hand, we get a common denominator. 1 is equal to 2 over 2. So 1/2 take away 2 halves would be negative 1/2. There's our new exponent. And I'm fine. Go ahead and leave your final answers with negative exponents and leave those 1/2 powers. The computer homework also will be just fine with that. And maybe what I'll also remind you is that in general, when you want to rewrite these roots, if you happen to have a little number in the pocket of that square root, it's got to be in the pocket, not a number in front, but in the pocket. And then maybe even a power underneath that radical sign. The power stays on top, and that root m goes on the bottom. Roots go on the bottom. So that can be how you rewrite a radical in general. Square roots get a little 2 because there's an invisible 2 in the pocket. Other powers, other roots would get an actual number. All right, another couple of rules, and then we'll tackle, remember our goal is to do the derivative of that polynomial all up at the top there, that f of x. So we need a couple more pieces. So rule number 3 says if you do in fact have something to do with x, f of x, which our only thing right now is a power, and you have a constant, a number, times that x piece, then that multiplying number just tags along. It multiplies as we work on our derivative. And here's the rule. This is a rule I tend not to give on the exam because it's easier just to do it rather than to worry about, oh, what's the rule? How does it work? So here's how it looks. So let's take the derivative of 2x to the third power, 2x cubed, right? The 2 that's in front, it's 2 times. It's going to tag along 2 times while we work on the x cubed. Work on the x cubed, the 3 comes down, we get left with a 2, and that 2 is still multiplying. So then 2 times 3 is equal to 6. So we get 6x squared. And hopefully, eventually, you will be able to go straight from the derivative of 2x cubed to that 6x squared. I don't need to see any work in between. And then just another one to think about, negative x, take the derivative of that. Negative x is like a negative 1 times x. So there's that constant of negative 1 floating around. Derivative of x, we saw up above, is just a 1. And so the derivative of negative x is negative 1. And again, hopefully, eventually, with some practice, you can go straight to that negative 1 from the original piece. So this rule ends up being super fast once you get the hang of it. So I tend not to give it to you on the exam. And then our last rule acknowledges that a polynomial is made up often of several terms. That original f of x has what, 4 or 5 terms in it. So we need to be able to know that we can in fact take the derivative term by term. And that's all that this rule is saying. If you've got more than one piece in a derivative, f plus or minus g, then we can take the derivative of each piece. So in words, we can work term by term. And so a very quick example of that, if I had 2x cubed minus 10, I would think this first step of taking the derivative of the 2x cubed, taking the derivative of the 10, and keeping that subtraction in between. And we already know that the 3 comes down, we get 6x squared. Derivative of a plain old number is 0. So then we just get our 6x squared as a final answer. Okay, and again, I tend not to give that rule because it becomes second nature. It's just sort of an automatic thing. So the first 2 rules are the ones I will for sure give on the exam. So let's give it a try. Now we can find the derivative of the original polynomial. So this was number 8, f of x equals 4x to the 4th plus 2x cubed plus 8x squared minus x minus 10. We've done a lot of these pieces up above. I will just remind you, this is a thinking step. I probably would not do this ever once I get past my first few examples, but I realize that, oh, I can just take the derivative of each piece separately. So I don't expect anybody to write this all out unless it helps you. So taking the derivative, putting the little brackets with the prime mark around each piece. And then this could also be a thinking step where we think through the rules with the power and then also with the number in front. So for example, the derivative of 4x to the 4th would be that initial 4, and then we get the 4 exponent coming down, and 4 minus 1 would be 3 for our new exponent. So again, I don't need to see this worked out step, but write our final answer, f prime of x, giving it a label. That first term gives us 16x cubed. And see if you can go from the original 4x to the fourth directly to that 16x cubed. And then 2x cubed, I think we did this one up above, but the thinking process would be 2 tags along, and then x cubed becomes 3x squared, so we get 6x squared. So please write out any step that helps you do these problems, but eventually, I don't mind if you don't really show any work at all. For 8x squared, the 8 tags along, the 2 comes down, and then we get 2x to the first power, and we're just going to ignore that 1 and get 16x, my final answer. And then minus, or I guess that'll bring it down below, the derivative of x is just a 1. So in my final answer, I get minus 1, bringing down that subtraction sign. And then the 10, we know, goes to a 0. So I don't have to show that in my final answer. And here we are. Here's our first derivative. 10 minutes ago, we didn't know how to do this. And now you know how to take the derivative of any polynomial. So f prime of x is equal to 16x cubed plus 6x squared plus 16x minus 1. And if you prefer the df dx notation, I'm totally fine with that. And I think I'll stop this part and we'll come back with a third part with more practice.